Okay, so now I'd like to talk about the chain rule. And the chain rule is used when we are taking the derivative, and the function we are trying to take the derivative of is a composition of two other functions. So let's take a look. It says if u is a differentiable function of x, so we have u of x, u is a function of x, and we have f, and f is a differentiable function of u. So f is a function of u, and u is a function of x. Then y equals the composition, the FOU of x, that's the composition, is differentiable, and it's a differentiable function of x. So f is a function of u is a function of x, therefore transitively f is also a function of x. Um, and here's how you would find the derivative. So the derivative y prime would be equal to the composition of f prime and the u of x. So this is f prime of the u of x multiplied by u prime of x. So what we have here is we take the derivative of the outside function f with the inside function u of x being the independent variable. And then we take the derivative of that independent variable, the inside function u of x, with respect to x. Um, and we multiply those two together. So equivalently, we could say that dy dx is equal to dy du, which is the derivative of this composition with respect to u, the inside function, independent variable, multiplied by du dx, which is the derivative of this function u with respect to x. Let's take a look at this thing in practice. All right, so here we have um, a function, and this function is a radical function. So whenever you get a radical function, you want to rewrite it, and you want to rewrite it in terms of a power. So you want to take this 7x squared minus 5, and you want to write it in terms of the power 1/3, which is how you translate this radical to a to an exponential. All right, so looking at this function, I see that the inside, the function on the inside, which would be u, I'm going to call u, that function, u equals 7x squared minus 5. So u is 7x squared minus 5. All right, in that case, y can be seen as u to the 1/3 power. If you make this u substitution, then this is just a power of u to the 1/3 power, right? Now I want to find dy dx. dy dx. In order to find dy dx, what we're going to do is we're going to use the chain rule version of the simple power rule called the general power rule. So the simple power rule says that the derivative with respect to x, notice it's with respect to x, the independent variable is x. So the derivative with respect to x of x to the nth, and they say that that's equal to n times x to the n minus 1. That's the simple power rule. But in this case, we can't use the simple power rule because what we have here, we don't have x to the nth power. What we have is we have some function of x, u to the x power. So we have to use the chain rule version. And the chain rule would say that the derivative with respect to x of u, which in this case u is 7x squared minus 5, to the nth power, in this case n would be 1/3, is equal to, and the chain rule says to take the derivative of the outside function, take the derivative of the outside function with respect to the independent variable. So that would be n, and the independent variable u to the n minus 1 power. So this is taking the derivative of the outside function u to the nth, taking the derivative of that function with respect to the um, inside function. So we're using the inside function as the variable. So u is being used as a variable. But then we have to multiply that then by the derivative of the inside function with respect to x. So we have to multiply that by du, the derivative of the inside function with respect to x. All right, so in the case of this here, to use this chain rule version of the power rule, which is called the general power rule, what we want to do to find dy dx then is we've identified n. We've said that n is equal to 1/3, right? So n is equal to 1/3. So the rule says that I'm going to take n, which is 1/3, right? N, which is this 1/3, multiplied by u. Well, u is this 7x squared minus 5 raised to the power of n minus 1. Well, n is 1/3, and 1/3 minus 1 is negative 2/3. But then I have to multiply that by du dx. Well, du dx is the derivative of u with respect to x. It's this. Du dx is just the derivative of this expression here. So du dx is going to be 14x to the first power. See, I can use the simple power rule there. All right, so that means then I'm going to multiply by du dx, which is this derivative, 14x. So here I have the derivative of y with respect to x using the general power rule. You can simplify this. Let's see. We can rewrite this. We'll get dy dx is equal to 14x over 3, 14x over 3 times the cube root of 7x squared minus 5 squared. So that's the cube root of 7x squared minus 5 quantity squared. All right, so there you have it. That would be the derivative of the original function. So we use the general power rule here, which is the chain rule version of the simple power rule. See, the distinction here is we're taking the derivative with respect to x, and this is x to a power. And in this case, we're taking the derivative with respect to x, but this is u to a power. But u is a function of x. U is a function of x. So they have a composition here, and we're using the chain rule to take the derivative. We just have to remember to take the derivative of the inside function. All right? So that's the chain rule version of the simple power rule. All right, so let's take a look at this next problem. So for this next problem, I'm asked to find f prime of x given f of x is equal to the sine of x squared. So in this case, I see that I have a composition, and the outside function is the sine function. The inside function here, u, would be the squaring function x squared, the function that just takes the independent variable and squares it. So here's what I want to do then. I'm going to go ahead. This then is really just the sine of u. So in that case, I know that the simple sine rule says that the derivative with respect to x of the sine of x is equal to the cosine of x. I know that's a simple sine rule, but there's a chain rule version that says the derivative with respect to x, so we're taking the derivative with respect to x, but it's not the sine of x. It's not the sine of the independent variable. It's the sine of u, where u is a function of x. So we have a composition here, And it says that this is equal to the cosine of u. We just have to remember to multiply that by the derivative of u with respect to x. So it's the same as the simple sine rule, except we have to multiply by the derivative of u with respect to x. So just like back here, the chain rule version of the power rule is just like the power rule, except I have to remember to multiply by the derivative of u with respect to x. So that's the generality about the chain rule. Okay. So here's our u. Here's our function. We're going to use the chain rule to take the derivative of this function. Right. So by the chain rule, then f prime of x, which is the derivative of this function with respect to x, is equal to, then, since it's the sine of u, then the derivative is going to be the cosine of u. That's the cosine of u, which is x squared. And then we're going to multiply that by the derivative of u with respect to x. Well, that's the derivative of this thing with respect to x. That's du dx, which would be equal to 2x. So I'm multiplying here by 2x. All right. So this is f prime of x. Let me just rearrange things a little bit here. I'll put the factors 2 and x in the front, and the factor cosine x squared last. So this would be the derivative of the sine of x squared. The sine of x squared. This would be the derivative, all right? So that's the chain rule with the sine function. And it works this way when the outside function is a trig function. You just have to know the simple rule for that trig function. And the chain rule would say to take that simple rule and multiply it by the derivative of the inside function. All right, let's try this one. Well, this one is slightly different. In this case, the function on the inside would actually be the sine, because this is the sine of x raised to the 1/2 power. So in this case, u is actually equal to the sine of x. So this is a little bit different than the last one. The last one, the sine was the outside function. In this case, sine is on the inside. So in this case, we're still using the general power rule, because this can be rewritten as u, which is the sine of x, to the 1/2. So you see that's a power function. So we're taking this derivative of u to the nth. So it's going to equal n times u to the n minus 1 times the derivative of u with respect to x. So we've seen this before. This is the general power rule. All right, so that means that this derivative is going to be the derivative with respect to x of the sine of x to the 1/2. Then this derivative is equal to, let's see, that's going to be n, which is 1/2, times u, which is the sine of x, to the n minus 1 power. Well, n minus 1 is 1/2 minus 1, which is negative 1/2, and then multiplied by the derivative of u with respect to x. Well, that's the derivative of this. The derivative of u with respect to x is equal to the derivative of sine of x is cosine of x. So I'm going to multiply this then by the cosine of x. All right, so that's the derivative. Simplifying a little bit, I get that this derivative of the sine of x to the 1/2 power, this derivative is equal to, it's going to be cosine in the numerator, cosine of x, divided by, and then I'm going to have 2 square roots of the sine of x. 2 square roots of sine x. All right, and there you have it. All right. Let's look at this example here. In this example here, I have a composition where my inside function, u, is actually the exponent. I have an exponential. So u is equal to negative 3x squared. So what this is, then, this is equal to e to the power of u. All right? Now, the simple exponential rule says that the derivative with respect to x of a to the power of x is equal to a to the power of x multiplied by the natural log of a. Okay, now in this case, a, the base, is e. So when you take the derivative, you're just going to get the derivative with respect to x of e to the x is equal to e to the x times the natural log of e, but the natural log of e is 1, so you just get e to the x. Now, the chain rule version of this says that the derivative with respect to x of not a to the x, but of a to the u, where u is a function of x, is equal to a to the u multiplied by the natural log of a, well, then that needs to be multiplied by the derivative of the inside function du dx. Well, let's see here. In order to do this, then what I'm taking the derivative up here to find dy dx, to find the derivative of y with respect to x. That's going to be equal to, well, it's e to the u, so I'm going to use the chain rule version of the exponential rule here. So I'm going to have e to the u power, u is negative 3x squared, multiplied by the natural log of e, multiplied by the natural log of e, multiplied by du dx, multiplied by the derivative of u with respect to x. Well, the derivative of u with respect to x is negative 6x. It's the derivative of this. So, therefore, we're multiplying then by negative 6x. So, to rearrange this a little bit, I get dy dx is equal to, and it's going to be negative 6x. The natural log of e is 1, that's just 1, multiplied by e to the negative 3x squared. So that would be the derivative of e to the negative 3x squared. And that is the general exponential rule. And it is just the chain rule version of the simple exponential rule. All right. Last one. Or maybe we have one more. Nope, it is the last one. All right, so we have the derivative then with respect to y of the natural log, or sorry, the derivative of y with respect to x needs to be found for y equals the natural log of the sine of x. So the composition here, I identified the inside function u. U is the one on the inside, it is the sine of x, the function furthest to the right, the one that's being plugged into the other. So that means that this can be rewritten as the natural log then of u. Well, I know there's a simple log rule that says the derivative with respect to x of the log base a of x is equal to 1 divided by the natural log of a multiplied by x. So that means that the chain rule version then is for the derivative with respect to x not of the log base a of x, but of the log base a of u. So this is equal to then 1 divided by the natural log of a times u, but you have to remember to multiply once again by the derivative of the inside function du with respect to x dx. So you have to multiply by du dx. In this case, since it's a natural log, we know that's log base e, so this would be the ln of e, which is again 1. The ln of e, once again, is 1. So let's take the derivative then. The derivative of y with respect to x is what we're asked to find, which is going to be the derivative of the natural log of u. Well, the derivative of the natural log of u, or the derivative of the log base e of u, is equal to 1 over the natural log of e, 1 divided by the natural log of e, times u, but remember u is equal to the sine of x times the sine of x, multiplied by du dx. Well, du dx is the derivative of u with respect to x. So that's the derivative of this thing. Du dx is equal to the sine of x. So I'm multiplying then here by the, oops, not the sine of x. Where's my head? The derivative of u with respect to x is the cosine of x. Cosine of x. So I'm multiplying here then by the cosine of x. All right, so then simplifying this a little bit then, we get that dy dx is equal to, well, that's the cosine of x for the numerator, cosine of x. And the natural log of e is just 1, so then this is the sine of x. So this is then equal to the cosine over sine is the cotangent of x. And there you have it.